So this lesson is going to be about quadratic sequences. So if I write it here, quadratic sequences, and what we're going to do is go through two questions. And by the end of these two questions, we will know how to do quadratic sequences. Right, so let's take it from the top with an example. So number one, if we have a sequence 7, 11, 17, 25, 35. At this stage, we don't know whether this sequence is a linear or a quadratic. So what we do is we look to see whether there's a common difference. So from 7 to 11, we've got plus 4. 11 to 17, plus 6. 17 to 25 is plus 8. 25 to 35 is plus 10. So we can see straight away that this is not a linear sequence because the common difference is not the same. So what do we need to do now? Well, what we need to do is take the second difference. So if I choose a different color, right, so 4 to 6, we've got a difference of plus 2. 6 to 8, plus 2. 8 to 10 is plus 2 as well. Now we've got a common difference here of 2 in our second row. This now tells us that we have a quadratic sequence. Okay. So if I just write it out here again, we've got 7, 11, 17, 25, and 35. And we know it's a quadratic sequence, so we're going to have an n squared. If I also list my terms at the top, the first term, now it's a quadratic sequence, right? So the first term, 1 squared, is just 1. The second term, 2 squared, is 4. The third term, 3 squared, will be 9. The fourth term, 4 squared, is 16. And the fifth term, 5 squared, is 25. So what do I do now? Well, step 2, I compare the terms. So what I mean by that is, how do I get from 1 to 7, plus 6, 4 to 11, plus 7, 9 to 17 is plus 8, 16 to 25 is plus 9, and 25 to 35 is plus 10. And we look for the nth term in that sequence. So if I just extract this here, we've got 6, 7, 8, 9, and 10. Common difference is 1. 1 again, 1 and 1. So we know this is a linear sequence. That's the first term, the second term, third term, fourth term, fifth term. So what's the nth term of this sequence going to be? Well, it's obviously going to be n plus 5, because 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, and so on. So if we put the two together, then we have the nth term of our series, which is n squared plus n plus 5, and that is your answer. Let's now have a go at question 2 and apply the principles that we learned in question 1. So question 2 then, if we have another sequence and it's 2, 9, 18, 29, 42. Again, we don't know whether this is a linear sequence or a quadratic sequence. So step 1, find the common difference, or find the difference and see if it's a common difference. So 2 to 9 is plus 7, 9 to 18 is plus 9, 18 to 29 is plus 11, 29 to 42 is plus 13. So that's obviously not a common difference, so therefore it's not a linear series. Now let's look for the second difference, see if that's a common difference. So 7 to 9 is plus 2, 9 to 11 is plus 2, 11 to 13 is plus 2. We can see there's a common difference of 2. So that tells us we've got another quadratic series here. So we're going to have an n squared in our series. Again, just like we did before, if we list our numbers at the top, so the first term, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So step 2 then, just like before, we compare these two numbers. So how do we get from 1 to 2? We add 1. 4 to 9, we add 5. 9 to 18, we add 9. 16 to 29, we add 13. 25 to 42, we add 17. If I just extract that and write it out here, we've got a series 1, 5, 9, 13, 17. Let's look for the common difference. That's plus 4, plus 4, plus 4, and plus 4. So we need to find the nth term of this. That's the first term, second term, third term, fourth term, fifth term. We can see the nth term is going to be 4n minus 3. Now, just like before, if we put these two together, we've got our nth term, which is going to be n squared plus 4n minus 3. That's going to be the nth term of the original series. And that is the end of the lesson.